Hello, everybody. Good morning and good afternoon to every one of us. I am Thiago. I am a project coordinator here at Encora Brazil Division, and I'm very pleased to be your host in this session. The session of today is Data Observability and Catalog for Modern Data Pipelines using Open Source Tools. Before to introduce the speaker, I would like to remind you that you can follow us in our social media appearing on the screen. So do it to be aware of every news, okay? Another important point, this session is part of Global Dev Week organized by Encora. And finally, you can use the chat to leave comments, ask questions to speaker, and etc. The speaker will be happy to answer all your questions also using the chat. All right? Well, so our speaker today is Alonso. Alonso is data engineer senior at Encora. Alonso is Bachelor of Computer and System Engineering with more than 6 years of experience in technology, specialized in data engineering, software development, and project management, having an advanced experience leading multicultural and multidisciplinary teams. I'm excited about this topic, and I think most of you are too. So let me invite Alonso to lead the speak. Welcome, Alonso. The stage is all yours.
Hi, thank you for that amazing presentation. Hello, everybody. Today we are going to be talking about data observability and catalog for modern data pipeline using open source tools. So first, pipeline architecture. What is the open source stack that we are going to be using today in this meeting? We have many tools that we are going to use today, so it's good to review each one. So first of all, we are going to use Docker. All the code that we are going to review today, all the technologies are containerized. We are using Docker for that. As you know, Docker is a software platform that allows us to build, test, and deploy applications quickly. And it doesn't matter if you are using Windows, Mac, or Linux. If you have your applications in a container, your project should work in any operation system. So then we are going to use Minio, that is a high performance object storage. An alternative to Minio is AWS S3 or or cloud storage in GCP. Then we are going to use dbt for transformations. dbt is data build tool. It's a tool that allows us to transform our data using the best practices in the market. After that, we are going to be reviewing also Airbyte, that is an integration platform that it's a no-code solution, make easy for data engineers and data analysts to move data from one source to a destination without needing to code. Then we will be using PostgreSQL as our database. We are going to create some layers in there, like we are going to be using medallion architecture. We are going to have our bronze, silver, and gold layers. And in addition, an Airbyte layer too. We're going to be using Airflow. Airflow is a data orchestration tool. We will be using Airflow to orchestrate our pipelines, to set an SKL, to set an owner, to let know our engineers what is the workflow of our pipeline. And finally, we will be using Open Metadata, that is an open source tool for metadata management. All the metadata that is generated by Airbyte, by Airflow, by dbt, by Minio, all that metadata is going to be stored in Open Metadata. So let's go with the pipeline architecture. We have two ways. First of all, we're going to be uploading some CSV files that we will use for this meeting using Airbyte. We will take those CSV files and will be ingested into Postgres. And then the second way is using Airflow and dbt. We will be using some transformations and applying data quality rules and setting descriptions, all of that using dbt, that it's a framework. And we will, in top of dbt, we will be using Apache Airflow to orchestrate the pipeline. Once we do the transformation, all that data is going to be loaded into Postgres. And in top of Airbyte, Minio, Airflow, dbt, and Postgres, we have Open Metadata that is in charge to grab all the metadata generated by the other tools and use that metadata to bring all that information to end users. So let's go quickly with some definitions. The first one, that observability. What is that observability? That observability is the practice and monitoring to ensure that your data is usable, has quality and reliability inside your company. So for all your users in your company, they need to be sure that the data that they are using is correct. And there are some pillars of that observability too. We have quality, that is in charge of applying quality to our data, like uniqueness, not nulls, if the data is in an acceptable range, like the values are in an acceptable range. Schema, if our table is changing, for example, if we expect a table with 10 columns, why that table today has only 5 columns? What happened with the other 5 columns? So that's another pillar of that observability. Then we have lineage, the upstream and downstream lineage, which are the upstream dependencies for my table, which are the ingesters of my table. Then we have freshness, how our data is updated. It's updated daily, it's updated monthly, hourly. Why is updated daily? Why is updated monthly? And then finally, we have the volume that refers to the completeness of our data. For example, if daily we are loading 1 million records, why today we only upload 1,000 records? What happened with the other data? How that observability works. So what is the input? The input for that observability, like we have as input the business glossary, some artificial intelligence, data quality rules, and cataloging and discovery. And what is the output that data observability brings? Volume, lineage, anomalies, data quality. So here we need to make a difference. As input, we have data quality rules, and as output, we have the result of the data quality rules. And finally, a schema. Data catalog. Why is important? Data catalog is one of the most common definitions to understand for anyone. Data catalog is a centralized repository that organizes all our metadata. It's like column descriptions, table owners, uh, file size, all of that. It's data catalog. All that metadata should be available for our end users. Data catalog allows our end users to do data discovery and collaboration. Also, governance, it's involved here because imagine if a new user comes to your organization and he needs to know if there is a table where all the customers are stored. What are the two ways that he has to know that? One is asking a teammate, and the other one is going to a platform or use a tool where he has all the metadata of the organization listed there, and he can easily type user, and he will see all the tables that has user information. Finally, data quality, what is and what is important. So data quality, according to the Dama book, is the planning, implementation, and control of activities that are applied to have a high bar of excellence in our data. So that way we make sure that the consumptions and meets the needs of all our data consumers. And all these three concepts, data quality, data observability, and data catalog, all of them belongs to data governance. Data governance, it's a huge topic to talk about, but in this meeting, we are just focusing on three: data quality, catalog, and observability. Some of the benefits of data quality: less time spent fixing dirty data, improve the improve and faster decision making, and compliance. We know that any country has their own regulations, so data quality allow the companies to uh, create a consumer-centric data-driven culture and to be compliant with the existing regulations. So now we're going to do the demo. So we will be using for this demo this repository, the open source data stack repository. And this is a project I have built a couple of weeks ago, in which I'm explaining detailing how to do the setup of all these projects. Okay, so this is a project that has Airbyte, Minio, Postgres, Airflow, and everything. We will be using this repository today to do our demo. So I have cloned that repository here, and I have my Docker files here that deploys all my tools. So the only thing I'm going to do right now is run docker compose app --build. Okay, right now all my containers are starting. If I open Docker desktop, here we can see that my containers are running. Okay, it seems all of them are running now. So let me go to here, and I'm going to open each of them. So we have Airbyte here, we have Airflow. Well, open metadata is still loading, is the one that takes a little more. And we have Minio here. So first of all, let's start with Minio. I'm going to introduce the credentials. Okay, so in Minio we have two buckets. As I told you, Minio is an object storage. It's very similar to S3, and Minio uses the S3 connector. Here we don't have nothing, and in raw also we don't have nothing. So the first step is we are going to be loading these CSV files into Minio. We have the customer CSV, the customer driver, and the loan transaction CSV. To do that, we are going to use an Airflow pipeline called upload data to S3. So here we have the pipeline. Airflow use this famous way to build pipelines that is called workflow as code. So while we are coding, we are defining the steps of our data pipeline. So here I have an start and end operators. Operators are common tasks common tasks, like for example, executing SQL statement, executing a bash command, executing a load of a file into a bucket like load storage or S3. Those common files are called operators those common tasks are called operators in Airflow. So we have the start operator, the end operator here, and we have this function that is using a decorator. This is a new pattern in Airflow that is using the S3 hook, because as we are using Minio, I told you before, Minio can use the S3 connector. So we are using S3 here, and we are uploading these three files. Well, all these files: customer drivers, and transactions. So in customer, we have information related to our customer. In customer drivers, we have the customer and some other columns like their monthly salary, their score, and their current debt. Imagine we are talking about loan transactions. And these are the customers of a bank. And finally, loan transactions here. We have the customer ID, the payment period, the loan amount, the currency type, the channel. It could be that the customer requests the loan using the web page, or going to an agency, or through a call. There are different ways to get a loan. And finally, the interest rate. So let's go to Airflow, let's introduce the credentials. And the first thing we need to do is creating the connection to S3. We're going to create the connection, and this will be here. Here is all detailed. I have the connection ID, and also I have this extra key that I just need to copy and paste. This works for any computer. So if you clone the repository, you just need to follow the instructions. So if I click on test here, this will fail, but you just need to ignore it. This is failing because Minio is deployed locally using Docker, but it's because Minio used the Amazon Web Service connection, but we are not connecting to AWS. So that's why it's throwing an error here, but you just need to ignore it. It will work. So once we create the Minio connection, then we need to create another connection from Airflow that is for Postgres, for our database. So I will paste Postgres there. I will set the connection ID that is Postgres default. The host will be Postgres data warehouse. And this is because this is what I have called my container here in my Docker Compose YAML file. Here Postgres was, the container was called Postgres data warehouse. So I can use this name to quickly reference that container. So this will be data warehouse, and the port will be 5432. I do the test, and in this case, it will work. I click on save. So once those two configurations are done, we can start our pipeline, and we can see that our pipeline is starting running. So it's loading at this moment the files. Well, as the files are very small, it loads all the 3 files very quickly. The pipeline has finished, but we know that we have here the execution rate, the execution date referencing September 10, 11, September 11, and September 12. And we can also have the graph view that is here. Another nice feature that Airflow allows us is that we can see the code of our pipeline just by clicking here in the tab code. And we can see all our code right here. So what we are going to do right now is it's uploading all these files to our database that is Postgres. Okay, so we are going to be uploading all these files into Postgres. As you can see here, I'm going to open the Beaver, that is the, and I have already the connection. And as I mentioned before, we have 4 schemas: Airbyte, Bronze, Gold, and Silver, because we are using Medallion architecture. And in any of these environments are tables, like they are empty. So what we are going to do right now is taking all these files and loading this data into Airbyte. Into the Airbyte schema. And for that, we are going to use Airbyte, that is a no-code solution. So first of all, I'm going to create the connections. That will be S3 connections. And I have the Airbyte configurations right here. So I'm going to set the source name, the output string name. This is the name that will be taken to create the table in Postgres. Okay. Then we have the patterns to replicate, the bucket name that is raw, Minio admin, and Minio password. And finally, we have the path prefix and endpoint. Okay. I will let these configurations as default, and I will just set up source. So here I'm just creating a connection between Airbyte and my source in S3. I'm going to repeat this process for the other files. We have configured customer information, but right now we need customer drivers. If I verify here, the fields are also getting up. So let's just. So what I'm going to do is now synchronize what it's in my buckets into Postgres. So if I go to my PostgreSDB and I refresh here, right now I have my tables. As we are using Airbyte by default is going to create 3 other tables that are for their own use to map the changes, to do the synchronization between the files and the tables. But this is metadata that it's only used by Airbyte. If we do a select statement on this, as you can see, we have 3 fields here: Airbyte ID, Airbyte data, and Airbyte metadata. In Airbyte data is our data, but stored in an string JSON. Okay. And the tables that we need are these ones, the ones that start with the prefix daily. And if I run this, we can see that we have our data here: customer ID, currency type, interest rate, but in addition, we have some Airbyte columns that are created by default. So what we are going to do right now is this is our landing layer for our data. We are going to take this data that is stored here in the Airbyte schema, and we will be using this data to create tables in our bronze, silver, and gold layer. Okay. So how we do that? We are going to be using dbt. dbt is a framework that allows us to do the data transformations using the best practices in the market. So here in this folder, I have my models, bronze, silver, and gold. But where I define this? I define all this here in this dbt project YAML file. Here I'm saying I will have models inside the data warehouse project, and those models will be called bronze, silver, and gold. And here I'm setting some default configurations, like the materialized type will be tables because we have also views. Then the schema for this will be bronze, and I'm adding 2 tags like landing and row. For silver, the same. I'm just changing the schema and the tags, and for gold, the same. Just changing the schema and tags. Okay. So in bronze, I will be creating views. I'm going to override the materialized type that was set by default in the dbt project YAML file. And here I'm setting, okay, create a view. And in case the schema change, fail. Okay, that's the 2 configurations I'm doing for my customer data. And dbt use a lot of wait statement. When you want to build something in dbt, you need to use a wait statement. So here I'm just saying, hey, use the Airbyte daily customer information CDC source to build a new table. What is the name of that new table? The name of the table that is going to be created in the reference layer is the name of the SQL file. Okay, by default, the tables or dbt creates the tables based on the SQL name file, on the SQL file, I'm sorry. And here in source YAML file, I define my 3 sources that are in my Airbyte schema. The daily customer information CDC that I can reference in my model by using Airbyte daily customer information. I'm just adding an Airbyte prefix to the real names. Okay, that's in bronze. Only views. In bronze, I'm only creating views and applying some transformations here of data type. In silver, I'm also applying transformations, but in this case, the materialized type is incremental because I'm going to be loading information incrementally. And all that information is going to be documented here in these YAML files. Here, I'm defining I'm setting a description for my table and columns. I'm also applying some tags and also some tests, okay? Like verifying, for example, that the customer ID shouldn't be null and it has to be unique. In the case of loan transactions, I'm using DBT Great Expectations to add extra data quality rules. Like, for example, the minimum payment period value should be 12 months. The minimum value for loan amount should be $1,000, and the mean value for interest rate is 5%. And in gold, I'm just aggregating my data. Okay, in my gold layer, I'm just aggregating my data or doing some joins. I have the YAML files also for these two tables right here. And what I'm going to show you right now is that I have created a model, an Airflow pipeline to run all that. Okay, so from this Airflow pipeline called run DBT models, I'm executing DBT. I'm executing each model, and I'm executing also the test I have defined. Where right here, I'm executing my bronze models, my silver models, and my gold models. And at the end, I'm executing the test for all of them. Finally, what I'm doing is uploading the manifest and run results files that are generated by DBT, because then I will be using open metadata to crawl these files and get all those metadata, all the metadata that is stored here. Okay, so let's do it. Let's go to Airflow, and let's go to DBT model, and let's run this. So right now, all our bronze, silver, and gold models are going to be run. If we can see here, it's just running the first day, that is 10th of September. And if I refresh, well, in bronze, I don't have tables. If I refresh views here, I have the views. And in silver, if I refresh tables, I have my tables here. For example, if I do a select statement against the loan transactions table, I have all the information right here. Okay. So all this information comes from these three tables, but are transformed using DBT. I'm changing some data types, I'm setting default values in case of nulls that we can review here in models, silvers, loan transactions. For example, if the loan amount is less than 1,000, I'm setting by default 1,000. All those transformations are done in DBT. So this is about to finish, so we can start with open metadata. Let's refresh this. So, and let's insert our user and email. So we need to create a database connection between open metadata and Postgres. So let's do it by selecting the database service and selecting Postgres. We are calling this connection Postgres production connection. And let's set the username, the password, the host and port, and the data warehouse. Let's test our connection. Okay, everything success. So let's save our connection. And now to grab all the metadata that is stored in Postgres and DBT, we need to set some ingester. We need to configure some ingester. So this finish, and let's do it. We are going to, first of all, set an ingester for the metadata. And we are going to be using fully qualified names. We are going to include views, but I don't want soft delete tables, so I'm going to unselect this option. And I'm going to trigger this manually. So let's run this, and we need to wait a couple of seconds here. In the meanwhile this is running, we can create another service, but in this case not for our database, for our pipelines. We can create an Airflow. service. So let's call it this Airflow Pro connection. And in host and port, in this case, let me check my configuration for open metadata. Yeah, we need to set this, the local host, and we are using, well, our Airflow instance is also using Postgres as backend. So we need to configure the backend for that. So let's do it. Airflow, and host Docker internal as port, and the database is Airflow. So let's test the connection. Okay. So we are going to create an ingestor also for Airflow. And we are going to trigger that ingester manually right here. Okay. So let's see if our ingester for Postgres has finished. Let's go to Postgres. And yeah, this has finished. So right now, if I click here on Explore, I will be able to see all my tables. The ones that were in silver, the ones that were in gold, the views that are in bronze, right here. If I select, for example, one table of silver, low and transactions, I see all the fields of these tables, but I cannot see the descriptions. I don't have tasks. I don't have sample data. I don't have queries. I don't have profiling at this moment. Also, I don't have data quality. I don't have lineage. So we need to add additional ingesters to complete all these information. So let's do it. Right now, I'm going to add the dbt ingestion that is using a string, is minio admin, minio password. In region, we can just set whatever, and the endpoint. Okay. So the bucket will be dbt, and the prefix will be data warehouse. Why? Because here we have a dbt bucket, and inside the data warehouse folder, we have the manifest and run results JSON files. So we are going to enable the update description, and we are going to set this into none. And we have the ingester here. We are going to, let me see, dbt, okay, this one. Let's run this. And we are going to create also a profiling ingestion. In this case, I want to filter the schemas that will be bronze, silver, and gold. I want to be doing I will be scanning all the table. That's why here we have 100%. And let's go next. And no. Okay. And let's run also this profiling. So we have run dbt at this moment. And let's go again to Postgres, sorry, to Explore. And right now let's review again the low and transactions tables. So in this case, our low and transactions tables has the descriptions per column and has the table description, also have the dbt tags that is curated, and all this information comes from our manifest JSON file. Okay. If we go to sample data, right now we have sample data because of the profiling. It should finish. In profiler and data quality, we can see that we have now the row count, the column count. In column profile, we can also see that the customer ID in this table is unique completely and distinct. We have also a small percentage of the one amount of uniqueness. And we have our data quality test that we apply, or well, that we configure in dbt. We have them right here, and we have the status of them as success. Okay. All this information, the ones that is related to data quality, come from the run results JSON file. Okay. And we also have lineage. We could see which tables are the upstream dependencies for our low and transactions tables, and which ones are the ingesters. Okay. If we go to silver layer again and we select customer information, we can see that the tags we set at a column level are also here. We have the PII tags for the first name and last name of our customer. And this will give, at this moment, not too much information, but let's see. This will tell us which users are using our tables, which queries are run against our tables. Okay, so this finish, and let's see if that works. Let's go to silver, log and transactions. And as you can see here, we have queries right now, and three. And these are the three queries that were run against this table, log and transaction. For example, this is the one I ran after we load information into that table. So we can see the queries that are run it against this table. And finally, we create another service that in this case, it wasn't a database service, it was a pipeline service, the ingestion finish. And as you can see here, we have all the pipelines that we have in our Airflow tool listed right here. For example, we know that we have run the upload data to S3 and the DBT model. If I select the upload data to S3, I have the list of my task right here. If I click here, this takes me to my Airflow instance and I can see the runs of that task. And also if I click on that, I could see in a graph view each of the tasks of my DAG, the same that I have in Airflow. I could see the execution of each task right here too. And I have lineage, but in this case, this is a small pipeline that doesn't use too many tables. That's why it's only showing one. And the same for our DBT model. We have the task here, and we have the graph view right here. And what about the others? We also have the others. For example, import soccer teams data. And if we go to DAG, we could see also the DAG, the dependencies, but in this case, they are in color purple. That means that this pipeline hasn't been run. Okay. And that's all the information we can get or that Open Metadata can provide to us as end users, as data engineers, as data analysts. All this information, it's very useful when we are trying to find new assets, to do data discovery, also to solve some problems. There are more advanced features that Open Metadata offers to us that we can review later or on our own. But I want to bring all this information to you guys, and that's all for now. Thank you a lot.
Amazing. Thank you, Alonso. It's amazing to know that all of those productive and very useful job could be done using just open source features. It's in the same time it's feasible, productive. It sounds so sophisticated, and using the best practice using open source tools. It was an amazing session. Thank you for your to share all your knowledge with us. Thank you again.
Thank you, guys.
Um, Thanks to all of your audience. I hope you enjoy as I enjoy that. And the final information, the next session starting now. Remember to return the official webpage of our events for you can see the agenda for new sessions and everything that is happening here. I hope to see you soon and bye bye.
Bye bye.